Hi, I'm John Dalby, and I'm going to discuss application framework design with you. For homework, we looked at the Graph Editor framework, and we saw that it's a graphical construction kit style framework that lets users select items from a toolbar and add them to a painting canvas. The application framework provides this nice graphical interface, and the plugin authors provide the items that go on the toolbar. For the first example, Horstman presents this geometric drawing kit where the plugin elements are circles and lines, and the framework provides the toolbar, the selection tool, and common functionality like delete. So a different plugin author could provide different items on the toolbar. They could be different geometric shapes, or they could be, for example, automobile parts or Legos, any kind of items that could be drawn on the canvas. The class diagram here shows the framework and a plugin, and I'd like you to take a moment and see if you can identify which parts of this class diagram belong to the application framework and which parts belong to the SimpleGraph plugin. So with a little study, you'll see that the framework provides these interfaces for an edge and a node and an abstract edge. So the plugin author provides the specific kinds of edges and the specific kinds of nodes. So circle node and line edge belong to the plugin, and in addition, SimpleGraph belongs to the plugin because it provides the prototypes of these elements that belong in the toolbar. Everything else here belongs to the framework. So you, as the designer of a framework, have a tough decision to make. Your goal is to try to make application developers more productive by providing reusable elements that they can combine to make their application. But so you want to provide something that's beneficial to developers so that they don't have to start from scratch. So you want to provide some basic functionality that can be extended upon, and yet at the same time you don't want to over-constrain the plugin developer. You want to create some sort of balance between productivity gains from reusing your code against the loss of flexibility and creativity that the plugin author has to put up with. So that's illustrated in this sketch here. The application framework's on the top and the plugins on the bottom, and there's a borderline in the middle here that indicates the design decisions you have to make to show where the boundary is going to be between what you're going to provide as the framework and what the plugin author is going to provide. If you the more that you provide in the framework, then you're more at this end of the spectrum, where there's less code that the plugin author has to provide, so they'll be more productive. On the other hand, what they gain in productivity, they lose in flexibility. the more code that you provide, the more constraints it puts on the plugin developer, so the less flexibility they have. So we don't want to go too far that way, or the plugin author will say, gee, I can't really do anything within this framework. It's so constrained. It's so limiting. I can't really accomplish anything creative, and they'll lose their interest. On the other hand, if your framework doesn't provide enough support, they'll say, gee, this framework is so thin, I have to do all the work myself, and it doesn't make me more productive. So deciding where this boundary line goes is a crucial design decision that you have to make when you're designing your application framework. The goal is to find some ideal distribution of responsibilities between the framework and the plugin. Let's take an example from Horstman. Let's say he's going to extend the graphical editor framework in order to make an electronic circuit drawing tool. In this case, what parts should the framework manage and what parts should the plugin manage? The framework will handle managing mouse clicks, drawing the canvas, putting items on the toolbar, and the plugin has to provide the ability to draw the shape of a transistor, for example, or other electronic components. So this is attractive to potential plugin authors because all the parts that deal with managing the drawing have already been done. So they simply need to provide the code that can create the specific shape they'd like to draw for the elements and then plug them into the bigger framework, and they've got a tool that works for them. So let's examine the constraints versus benefits in the graph editor framework. The constraint is that there's really only two kinds of components that can be put in the graph, nodes or edges. But the benefits are that the tool makes it easy to connect two nodes, and when you move one node, the other edge automatically goes with it. As we can see in this diagram here, when you select a node and move it around, the edge automatically moves to go along with it. And that functionality is really crucial in a drawing tool, taken care of automatically by the framework. So there's a balance here. You get, as a plugin author, you get some benefits, but you're subject to some constraints. And hopefully the framework makes it appealing enough that the plugin author can accomplish their goals within the constraints that are forced by the framework. Let's reflect for a minute on some hypothetical new features and to see if we've got this picture down between the borderline between the framework and the plugin. Let's say we wanted to add copy and paste so that we could copy elements and paste them into different parts on the canvas. Would that be a responsibility of the framework or a responsibility of the plugin? I would argue that that belongs as part of the framework, since it has to do with drawing and the graphical capabilities of the tool. As opposed to in the electronic circuit drawing program, if there was a function to calculate the current in a particular circuit, that would be something that only the plugin can do because it's specific to the focused domain of electronic circuits. But the answer isn't always as straightforward or consistent as it is in this simple example. For example, you might want to add an undo feature to the framework, and that so that after you've made some manipulation of the canvas, you could undo it. So that obviously belongs in the framework, in the graph editor. But if we were creating something like the sentence game, undo might be something that only the game knows how to do. For example, if you wanted to undo an anti-vowel in the sentence game framework, undo is not something that the framework can perform because it requires access to the data structures inside the sentence game plugins itself. Another example could be adding an icon to the toolbar. Could be part of the framework for the graph editor. But if you're writing an extension for the BlueJ IDE, the menu item is part of the plugin that you're creating. So it's not always really obvious where it belongs just by simple formula. You have to really examine the specific situation. In another example of a design problem, let's say we wanted to build a game framework, and one part of the game framework that we as plugin authors are going to provide is a Hall of Fame. Since Hall of Fames are common in many games, if the framework can provide the Hall of Fame, then that saves the developer from having to create their own. Usually when you add an item to a Hall of Fame, you add a player name, and you associate perhaps a score or some other numeric quantity with their name. So we'd want to have probably a dialog box in which the player can enter their name, and then the plugin will record whatever numeric value is to be associated with their name. So we might want to provide some confirmation, such as your score of 0 will be entered into the Hall of Fame, but the framework can't really know what that actual text will be, because the numeric value might be a score in some plugins, but it could be a time in other plugins whose goal is to achieve the winning goal in the shortest amount of time. So the actual word score is probably not something that the framework can know about. So only the plugin knows that. How is the plugin going to inform the framework what it should do? So proposed solution number 1 is that the framework provides an abstract method, getEntry, for example, or type, that returns a string, and the framework then uses that string where appropriate. Another example is just to have the literal string provided as a parameter to the framework. Or you might sort of finesse the entire decision, and without referring to the particular data type in the framework, and just leave it vague and say that 0:00 will be entered. So there's a lot of very small decisions that go into making a framework, each of which will impact how much creativity you're leaving up to the plugin author and how much support that you will provide in the framework. Horstman has a number of recommendations. He says that building a framework requires a very extensive understanding of the domain that you're building the plugin for. That you should try to shield developers from internal mechanisms, and at the same time provide adequate hooks for developers to access functionality that's available in the framework. He suggests that you can't really know if you have a good framework until you've built 3 applications with it. In other words, you probably need to build 3 plugins for your framework as sort of pilot tests before you can feel confident that your framework has struck the right balance between productivity and flexibility. Sometimes the framework might not even be the right approach. Sometimes you should just create a library. Frameworks are for specific domains, like board games or drawing tools, whereas libraries are not domain specific and provide some specific services, whereas the framework provides a rather broad infrastructure about a specific domain. I like to use the analogy of a theater, and in the theater analogy, a library would be like costumes, props, and a script for the play Hamlet. Whereas a framework is like having the stage and the scenery that could be used in other plays as well. And actors are like the plugins. You can have different actors take the same role, and actors use the library services, but they plug into the framework. And the last big design decision you need to make regarding frameworks is the difference between making your framework customizable versus making it extensible. Customizable means that you can tailor certain superficial aspects of the framework, versus extensible means you can provide new functionality. So, for example, a card game that allows the user to provide images for the card faces, we would say is customizable, because you're changing the visual appearance. Or, on the other hand, a card game that allows a developer to provide an implementation for a method such as is game over. We call that extensible, because there's actually some working functionality that has to be provided by the plugin. One way to think of this difference is the difference between static data versus logic. So static data are things like image files or other preferences, versus logic, which requires a code or an algorithm to achieve. And the best frameworks use both of those strategies in appropriate ways to allow the plugin author to create the kind of application they desire. Okay, let's look at some examples of poorly designed frameworks. In this framework, we have a class diagram showing that we have a GUI and a game, and that uses the observer pattern, and that a plugin will extend the game, and that the framework will provide a user interface that has some blank canvas and a toolbar with some buttons on it. So the problem with this framework is that it provides too little support. We say that it's too flexible, or that it's too thin. In order to create any kind of game from this framework, the plugin author is going to have to do a lot of work. On the other hand, this framework is a framework for Minesweeper games. And the framework allows each game to vary the size of the board. Each game can use different images. Each game can have a different number of points per move. Each game can indicate whether it's going to let the user reset the game and whether it will let the user undo a move. The problem with this framework is that it's really too narrow, or it's too inflexible. In order to create a different style of Minesweeper game within this framework, the plugin author doesn't have to provide any logic. There isn't really any extensibility required. All of these settings can be configured when the application starts via a preferences file, for example. And they're just sort of superficial, customizable options. And the only kind of game you can ever play is Minesweeper, but with just a few different kinds of settings. So we would say that this framework is too narrow or maybe too thick. So you'll want to avoid these kind of problems if you can when you're building your framework, and shoot for the balance that gives the support that a plugin author needs to save them work, and providing common functionality available to lots of different plugins by anticipating what features are common across all instances in this problem domain, and yet provide some creativity and flexibility so they can make their application appear to be unique or different from other applications in the same domain. That ends this short discussion. Thank you.